I'm Rubina.
And I'm Layla.
Welcome back to our channel, Nutrition Unpacked,
where we try diets so you don't have to.
We're still talking about intermittent fasting.
We are. I'm glad to have not been intermittent fasting for the last 2 weeks now.
Yeah, we did it for 2 weeks just so we can really experience it and understand it from a living it perspective. Mm-hmm. Early on, one of the first diets that we took on was paleo. We did that for 4 weeks and we're like, well, you were more like, never again am I doing that, 2 weeks max. And I was like, I'm with you. Mm-hmm. Let's do that.
Mm-hmm. Yeah. I feel like also because we do so many of these diets, I just can't always be doing a diet.
It's a lot to think about.
It is. And it makes me really empathize with, people who are taking on either new long-term lifestyle things or people who are, doing different kinds of diets all the time, which is not uncommon. Yeah. And just empathize with, oh my God, this is so tough, just mentally, socially. We've done intermittent fasting for a couple weeks. How are you feeling in terms of, vigor and just life, your life? How are you feeling? Did you feel like you had more life energy, life force? You were gonna live longer?
Vigor was lacking.
Mm-hmm. I won't be eating till 1 and I'm so hungry.
Okay guys, it's 11:45, but I can't wait anymore. I'm going for it.
I'm so hungry.
I still have about an hour to go. I'm starving, guys. I'm starving.
It is 8 a.m. and I'm now drinking my tea, and I will let you guys know I'm starving.
I'm just having my black coffee and praying that the caffeine does its appetite suppressive thing. I'm super excited to be talking about this because so many claims around intermittent fasting or time-restricted feeding on longevity. Not just, oh, you'll be healthier, but you're straight up gonna live longer. Those are bold claims, which I don't really hear about with other diets.
And this longevity thing isn't new, and it's been talked about in a lot of different forums. I've seen it less so on the social medias, but more on some of the podcasts that are out there where they're dissecting studies, and sometimes they're like, this study was done in a mouse. Everyone should do this too. Those?
No, they don't mention that it was a mouse.
Oh,
they just said there was a study.
When we're starting to talk about longevity, we should define what exactly that is.
So longevity is often described as the capability of an individual to live beyond the average age of death. We can't talk about longevity without talking about aging. When it comes to biological aging, that's basically describing the series of biochemical, structural, and functional changes that occur across our entire body, all of the systems, cells, tissues, organs, that ultimately kind of disrupt the homeostasis, leading to our death.
Aging is a big topic. Everyone goes through it. Science is still really heavily investigating what actually leads to this. When we talk about intermittent fasting, this has been one area of research where science has been going down of, oh, maybe could this be the fountain of youth?
I'm kind of surprised how long people have been looking into this. And even since the early 20th century, people did studies on things like rodents and crustaceans. It was found that calorie restriction seems to extend lifespan.
Similar research that's done today, and it's pretty consistent. Calorie restriction can reduce the prevalence of cancers in rodents and extend lifespan of all kinds of different creatures, including rodents and primates. And it's not a short increase in lifespan. Some studies show lifespan increases of up to 50%. Depending on the type of fast and the species.
We're not saying that intermittent fasting is going to do that. And actually, a lot of these studies are kind of more in the angle of calorie restriction as a whole, as opposed to any specific intermittent fasting protocol. However, we did talk about in our video on intermittent fasting and weight loss that intermittent fasting can be a tool that's used to achieve weight loss because it can support calorie restriction.
A lot of the evidence in this area is kind of mixing the two things together, and intermittent fasting is kind of a newer concept, so there isn't as much evidence there, but kind of this line of inquiry has really come from the research that's been done over the past over a century on caloric restriction. This has also been an area of inquiry of, does caloric restriction lead to longevity in humans? Humans are tricky. I think that's kind of the theme of every single one of our videos, is that studying humans is really hard. So we have very limited data on this, and it would be hard to do because you'd have to get a bunch of people and have them do calorie restriction for their whole entire lives.
That being said, there actually is one randomized control trial that was done over a 2-year period. These healthy, non-obese participants, they were supposed to take on a 25% calorie restriction. It ended up being closer to 12%. Nonetheless, we saw improvements on a wide variety variety of cardiometabolic variables, including reduction in weight, reduction in blood pressure, improvements in blood lipids, insulin sensitivity, as well as a reduction in inflammatory markers like C-reactive protein.
A lot of times we associate, these kind of changes in biomarkers with weight loss in and of itself. But what's interesting in this study is that even controlling for weight loss, calorie restriction on its own, even this smaller calorie restriction than they were going for, that 12%, still resulted in improvements in all of those biochemical markers.
And what's crazy is, so this was done over a 2-year period, but some of these improvements were seen even just after a few weeks of this calorie restriction.
This study mirrors a lot of the research that's already been done in, overweight and obese populations. Every basically diet study you've ever seen is a calorie restriction study. So it's not really groundbreaking that calorie restriction is going to lead to improvements in biomarkers. That's kind of just an established fact at this point. But what was interesting is that in this population, they had already healthy, non-obese participants, which is kind of different from before. So that way we can kind of parse out the effects of, is it like being obese that's causing these negative changes in biomarkers, and then maybe losing weight that's causing positive changes. They were able to kind of parse that information out. A lot of research that's been done before hasn't really looked at, is it the fact that the people are reducing calories or that they're losing weight? Most of the time we just go straight to that weight loss as like the mechanism, when it might be a little bit more complex than that based off of what we're seeing from animals and this one study in humans.
A lot of the research that we just talked about was about calorie restriction in general, which can be achieved through a wide variety of strategies. The research on intermittent fasting, specifically on longevity, is a little bit more limited, but we do have a few things that we can talk about. There are some animal studies on this topic. So in nematodes, when they do alternate day fasting, it seems like their lifespan can actually increase up to 57%. And if they did even longer fasting periods, that seemed to extend their lifespan even further than that.
In these nematodes, there's like these worm-looking kind of gross things. Insert a picture of a nematode here.
I don't know if I'm gonna do. Is it gonna gross me out? I don't know if I want to look it up.
I don't know. I know you're not good with insects. Are you okay with worms?
Not if there's like a lot of them.
Well, you need to know it kind of looks like a worm. So some of these studies, they actually did really long periods of fasting where they kind of just like starved them for the rest of their life, and they actually found that nematodes that were starved until they died lived longer than ones that were doing just general calorie restriction.
Isn't that bizarre?
It's weird, and I don't think that translates to humans.
I mean, it obviously doesn't.
We know humans die after
not eating.
Yes, and nematodes only live for a matter of like days. Yeah.
So I mean, I think the lesson here perhaps is that maybe nematodes are not a great animal model for this question.
I don't know. I'm not
not our area of expertise.
Not our area of expertise, really, but I would say, there may be some limitations in that. Great first step. But I think, these kind of studies, these are used on blogs where they're talking about why you need to be doing intermittent fasting. It's used on like podcasts and stuff like that. People love to turn to our animal friends.
Rodents also, we see a very similar finding where alternate day fast or fasting once every 3 to 4 days also seems to extend their lifespan. We also see that time restricted feeding in rodents seem to be helpful with tumor suppression and again, supporting longevity.
These studies have gotten like a lot of hype around them. People are pointing to these as like, oh, we need to be fasting to improve longevity. But again, I'm not a mouse, you're not a mouse, you're not a rat, you're not a nematode. These protocols that they're putting these animals on are actually quite well controlled. They're in a lab. They have like a lab technician giving them all their food. Everything they eat is exactly the same. It's like rat chow or mouse chow or whatever. And also they're starting these animals on these diets at a very young age. So it's kind of a little bit of a step too far to then go, and so therefore humans should all be doing intermittent fasting too, because my study in a baby mouse showed that mouse lives longer.
So let's talk about the research on humans and intermittent fasting then. And there are a number of studies on this topic. And again, we do actually see that even intermittent fasting in humans can improve a variety of cardiometabolic variables, lipid metabolism, glucose metabolism, inflammatory markers, lower blood pressure, and kind of just improve cardiovascular health as a whole. In this type of context, these types of studies, it's really difficult to know, is it something about restricting food intake to specific hours or days? Is that what's changing all of this? Or is it simply calorie restriction and weight loss that's leading to these outcomes? A lot of these studies are done, as we kind of mentioned earlier, in those that are overweight or obese. And it's just difficult to know, Is it kind of the shifts in adiposity that's changing these outcomes? I mean, there's still some questions.
When we look at periods of extended caloric restriction or fasting, we do actually see changes in physiology, which we talked about in week 1. So we talked about how your body is adapting, you get differences in hormones that are being produced, your body uses energy differently. There are quite a few different changes that happen. There are more specific changes that scientists are looking at for, okay, how could this kind of fasting or caloric restriction lead to extended longevity?
There are some mechanisms that have been proposed, like when they look at the animals and kind of on a cellular level, seeing how certain processes change and kind of how the animal happens to live longer. Like, is this what's happening? The way this type of study works, it's like you make a connection between like 2 things, and then there's like another study that looks at a connection between that outcome and some other outcome, and then we're kind of like, kind of saying like A seems to lead to B, and B seems to lead to C, and C seems to lead to D. So does A lead to D then?
I don't know.
That's the question, but I mean that is why science is a process, and it's often slow. But let's talk about a couple of these proposed mechanisms. I'm gonna say, full disclosure, this level of like cellular biology is not my area of expertise. These papers are like not easy reads.
They're dense and also really weird. Like, I don't know, I'm used to like human nutrition studies where it's like introduction, method, results, discussion, conclusion.
Yeah, these studies are different.
They never have a method section. I don't know why, but like the methods are just like in with the results, and sometimes the results and the discussion are all together. It's really weird to me. So that seems like bad science reporting in my opinion, but maybe I'm missing something.
It has nothing to do with exposure and familiarity.
No, it's just objective. It's objective.
Nutrition science is the way that everyone should be doing science.
One of the processes that might be implicated in this changes to lifespan with caloric restriction is called the TOR pathway. And essentially it's thought that if you can achieve caloric restriction without actually being malnourished or without causing malnutrition, that can down-regulate this particular pathway called the TOR pathway. When they've looked at research and things like yeast and worms and flies and mice, down-regulating this particular pathway seems to extend their lifespan.
I don't know. We don't know if this applies to humans as of yet. TOR plays important roles in growth of cells and like muscle synthesis and synthesis of all kinds of different things.
The downside being that down-regulating this can compromise growth. So, I mean, especially when you're like then looking at humans, like what does that actually mean? Yeah, we get lots of questions.
The next mechanism that's been looked at is the impact of something called fork head box protein O on growth hormone. So you guys might have heard of growth hormone. It does exactly what it sounds like. It helps you grow, proliferate cells, get bigger. Children who are low in growth hormone tend to be a lot smaller. When we have periods of caloric restriction, we see that our growth hormone goes down, which makes sense because your body's like, okay, how? I'm not gonna be growing anything. I have nothing to build with. I have no energy. I have no building blocks. What am I doing? Growth hormone levels go down, and then this protein called the fork head box protein O is produced in greater quantities. This signals to your cells to kind of repair themselves, resist some stress and detoxify themselves and just kind of, just be better. This can support longevity. Again, the models we're looking at here are not humans.
Another proposed mechanism of why intermittent fasting might support longevity has to do with our circadian clock. So you guys might be aware, I feel like circadian rhythm, circadian clock, those are terms that are often thrown around. Essentially, it's this idea that we've evolved to kind of be awake and go to sleep and do certain things at certain times-ish. Like generally speaking, humans, we tend to like to be awake during the day when the sun is up. We tend to sleep better and have better health outcomes when we sleep at night as opposed to during the day. Perhaps there might be something similar that might be supportive when it comes to longevity, when it comes to the times that we actually eat food as well. For example, in studies in mice and flies, it seems like a really well-functioning circadian clock actually extends their longevity. It's thought that perhaps having like time-restricted feeding or some intermittent fasting protocol could really strengthen that circadian clock in humans as well. I think this is more kind of just a loose hypothesis more than anything at this point, but I guess it kind of maybe tracks with what we see with other areas of our lives, because even when it comes to something like sleep, people that are doing shift work or do night shifts, we do see that there tends to be compromised health outcomes.
Like different animals have different hormones that rise and fall at different times in the day. Even related to nutrition, I know leptin, I think, has like a 24-hour cycle. And so there's so many other hormones, including like melatonin and cortisol, that are fluctuating throughout the day. And there's a belief that, the interaction of these hormones and other hormones with the changes that happen when you're eating might cause either increases or decreases to longevity. We have compounds in our body called sirtuins.
We're guessing how to pronounce it.
Yeah, so I don't know. I saw this word for the first time this week. Don't judge us. If you're a biochemist or something, feel free to give us a little pronunciation lesson in the comments. We appreciate it. These are like little cellular clocks that help us regulate our body's function. So this is kind of related to what we were just talking about before with the circadian clock. When we're under nutritional stress, which means we're not getting enough to eat, there is a compound called NAD+ that increases in concentration, because normally when we eat, that NAD+ turns into NADH, but when we don't have any nutrients to process, that NAD+ just stays and accumulates. What happens is as these levels go up, we see these sirtuins get activated. Sirtuins get activated when NAD+ increases in times of fasting and caloric restriction. Many different animals, all from yeast, which are not animals, but whatever, to mice, this can make them live longer. We can see that science really is looking into this question, and it's not really a new question. For over 100 years, we've been looking at, okay, caloric restriction actually does increase longevity, and like trying to figure out kind of how that happens. And so these are just some of the ways that science has looked into and been like, hey, we do see these changes in the body of other mammals and other animals. Could this apply to human beings?
I'm just so intrigued by what it is about caloric restriction that does this and what we can actually take away from it, because we also know that we need certain amounts of certain nutrients to be able to not just live, but actually live well and healthfully. Even if there was really something about caloric restriction and some intermittent fasting protocol that could achieve longevity, how do we find that balance so that we can still make sure we're getting enough nutrition so that we can be productive at work and be able to live our lives in a happy, healthy way, have healthy bones and mobility and functionality and cognitively, whilst also extending life?
That's a good question, because I was definitely not happy and not thinking very well when I was doing intermittent fasting. So I think we just need more research in humans before we start making these bold claims that we're seeing on social media, on podcasts, on wherever else. And it's exciting. It's really cool stuff to see, like, oh, this mouse lived like 50% longer. That's awesome.
So crazy.
But I just don't think we're at the point yet where we can jump to this being the case in human beings. And I'd say if you are doing intermittent fasting for longevity, I don't know if there's enough research to support that as of yet. And I don't think we have research to like balance the pros and cons like you just said.
If for whatever reason intermittent fasting is still really calling your name, you want to experiment with it, I would love for you to do it in the most healthy way possible. Watch out for our next video where we're going to talk all about how to do intermittent fasting in a way that'll still allow you to meet your goals, kind of follow the intermittent fasting protocol, but still be able to kind of thrive and function and feel happy and energized.
So we're coming up to the end of our intermittent fasting journey. Thank you guys for coming along with us. We got one more video. Make sure you like this video, you comment on this video, you subscribe, hit the notification bell so you don't miss our next video on how to do intermittent fasting right if you decide to do it. And follow us on our Instagram and our TikTok.
Thank you for watching.
Bye.